So I wanted to spend a little time together today talking about how to architect and select the best system for AI applications. It'll probably groan, okay, just another vendor pitch. My promise to you is that we will not spend 20 minutes today talking about buy my server. It's not who we are as a company, who I am as a person, but instead I want to kind of share some practical advice on how you may want to operate when you're looking for an AI system, when you're looking for an AI hardware deployment. And with that goal in mind, I want to say just a little bit, why should you believe me? Well, I architected HPC clusters and GPU systems for about 6.5 years at Microway. I worked with thousands of customers on hundreds of deployments, designing and speccing out the hardware. Then I moved over to the IBM HPC group and led the HPC product marketing for them for power servers, i.e. those used in the Coral deployments, Summit and Sierra. And I also helped start the marketing for AI infrastructure at IBM, for example, and software as well, for example, Power AI in the same power systems division. So some of you may not know who Microway is. Just very, very briefly, we're a longtime HPC and AI systems integrator. We've been doing this for over 35 years and serving the HPC community from our start. We were one of the earliest to jump on GPU computing in the 2007 to 2008 era, when GPUs didn't even have a computational variant, a solely computational variant. And we're an early leader in AI systems. And I'm part of a technical team that's full of people who spend all day designing and delivering a huge quantity and, more importantly, a huge diversity of HPC and AI systems. So that's why we see a lot of hardware, we see a lot of different use cases and end users. It's one reason why it makes us interesting to listen to in some sense. So with that in mind, that's the end of the who we are and why, really, for the moment. And let's move on a little bit to where we're headed today. So I want to talk a little bit about what you do before you start this exercise of selecting an AI system, i.e., how do you lay out what you do know about your data set, about your algorithm, about your collaborators, and how that's a useful methodology for walking into the hardware architecting and selection process. Talk a little bit about a few templates for how you select a system when you're doing a common AI training workload, when you have a mixed workload, when your data set is too darn large to fit on any type of system, and when you don't know much about your data set or algorithm as well, what do you do? And then finally, a little bit about collaborating with vendors when you're trying to go out and obtain that system. Who do you look for? Where do you look for people, and what kinds of people? And then what to look for in the people that you're dealing with so that you have a more effective engagement. So with that in mind, who is this really for? This is for the kind of end user who doesn't really know where to start when looking at hardware infrastructure for AI and deep learning. Might need a checklist or a recipe, something to follow along the way. If you're afraid of or hate working with vendors, like many of us do, or if you just simply hate being sold to. Who is this not going to be as useful for? It's probably not going to be as useful for an AI framework writer. You're going to have much higher level insights into system architecture than these kind of more generalist guidelines. This is not for a 10-year ninja GPU coder as well. You're going to be able to write an algorithm that's going to far surpass any architectural choice you might make on the hardware side or any kind of variation. So with that in mind, before you start selecting that piece of AI infrastructure, what is the first question you really need to ask? And the first question you really need to ask in a lot of different ways is, what do you know? And what do you know, for example, to start about your data set? What's the size of the data set overall? Is it so big that it will never fit into a single GPU in its entirety? Will it fit into a single GPU? What GPU? Is it going to fit into a number of GPUs in a single system? Is it so large that it's absolutely going to be a multi-system kind of deployment? The second piece about what do you know about your data set is it, and for a little more colloquial term, is it chunkable? Can you group it into different sections? right? In the deep learning and AI world, you start to get into discussion about batch size, and that's the more technical way of describing that. But can you fit your data into different chunks that are approximately the size of a GPU, or a portion of a GPU, or a few GPUs as well? And then finally, what is the size of each individual piece of data? What's the individual size of a data? Is it something that's so large that it couldn't possibly fit into a GPU at all? Is it something that would fit into a single GPU, many fitting into a single GPU? These are important things to really lay out and have ready so that you understand how it maps to the hardware architecture that you might be selecting in the long term. So kind of a very crude visual representation of this is here on the right? Maybe the top is your entire data set, this group of images that you're trying to do training on. And overall, the data set is 128 gigabytes large. It's filled with many smaller images. Because it's images and it's filled with many smaller ones, you might be able to group them to fit onto individual GPUs. It's a good case for a single multi-GPU server. Or maybe the individual size of each piece of data is so large, say it's the full 128 gigabytes, couldn't possibly fit into a GPU. That'll dictate a very different hardware architecture. Or similarly, if you had a piece of data that's 16 gigabytes large, maybe you can fit it in, only a couple into a single GPU, or smaller, yet smaller pieces of data as well. Similarly, the what do you know question, what do you know about your algorithm? Are you running a standard deep learning framework or AI framework, or are you running something that's completely customly coded on your side? Have you done anything to look at how this thing works, right? Have you run any profilers or any tools, performance tools like the ones up top? In particular for GPU accelerated algorithms, something like NVProf, but things like the Alinea, now ARM performance tools are out there, the Intel Visual Profilers, and so forth. So you can kind of think about this, your algorithm as being on a spectrum, right? On the far left, you have something that's really one of the standard frameworks, or one of the more packaged things that are out there. And on the far right-hand side, you have something that's completely custom. And your hardware architecture varies widely based upon where it ends on that spectrum, or where it lands on that spectrum. And in the middle, you kind of have people who have a mixed workload. Maybe they're running AI and deep learning, but they're also concerned with, hey, this piece of hardware is going to also run a traditional HPC workload, and that kind of sits in the center. So you have very specialized hardware architecture on the left, denser. It'll be more NVLink interconnected because there's a performance dividend to that. You'll have a mixed workload, which will be kind of balanced. We can talk in a bit more detail about that later. And then something that's completely custom on the far right-hand side, well, that'll map to a couple of different variants that we'll talk in more detail on. So the final piece about what do you know is, what do you know about your collaborators? And this is one that I think people really underweight out there, having worked with many, many, many different customers. People are so focused on the concrete hardware value, how much they're paying for the hardware, some kind of complicated price performance metric, or even a simple price performance metric, someone who says, oh, what's my maximum, dollars, maximum flops per dollar, right? That they kind of lose sight of the efficacy metric of the installation they're about to deploy. And if you and a primary collaborator that you have need to dramatically change your prep steps on your data, or your runtime instructions to have a similar looking run and actually work effectively together, then you're getting far less time out of your expensive hardware investment. And you've in some sense, you've wasted some of your spend in that way too, trying to optimize purely for a hard performance metric. So spending 30% of your time on this transition isn't practical. You want to think about this before you walk into any kind of hardware selection process. Similarly, if you have an opportunity for a much larger run on a much larger deployment, something like, for example, Summit or Sierra, think about whether you want to mirror the architecture of that larger deployment so that you spend less time on this portability challenge. So with that, now that you have a little bit of data, that you've thought about this, what do you do about that data, about your data set, that you've learned about your data set and your algorithm, and how do you translate that to architecting an AI system? So if you're working with something that is solely an algorithm for AI training, and you're doing it with the most common frameworks, you're probably going to want to start mapping to an NVLink connected system and start scaling up to the GPU count that fits with your data set scale and budget, assuming your data set will fit into any one of these pieces of hardware. So you can start out with a system, for example, that might have 4 GPUs, all NVLink interconnected, scale to 8 GPUs, all NVLink interconnected, or 16 GPUs, all NVLink connected, like the HGX2 platform. And why NVLink in this case? Why an NVLink connected system first for consideration? Well, as we've evolved over time, NVIDIA's done a better job of optimization of frameworks for the NVLink interface. You're starting to see about a 10 to 20% performance dividend for a training workload on a 1U, for example, with 4 GPUs that are NVLink connected versus that very same system where it's just a PCIe type of connection between GPUs. So if you end up having a bit of different needs, you could secondarily start to think about a switch PCI Express-based system with this same kind of GPU count and scaling up to your budget and data set size. Kind of a bit of a corollary to this is if you're only training, but you especially care about ease of use and an NVIDIA blessed software stack, you would map very well to NVIDIA DGX systems. And that's DGX Station, DGX1, and DGX2 at the biggest scale. Same kind of hardware architecture that you saw before, but with that blessed software stack, with that far easier ease of use, with someone else doing the optimization on the frameworks through the NVIDIA GPU container stack. If your assessment after thinking about those early questions that your workload is really blended, that your data set is going to fit into a single GPU or a small number of GPUs, or that you have an algorithm that may be a training algorithm, but you're also finding it really important to run a more traditional HPC workload on the same system, you're probably going to find that a balanced system is the right match for your set of applications. People often knock these kinds of balanced systems, right? 2 CPU sockets, a pair of GPUs, 2 CPU sockets, 4 GPUs as not the most performant. But I would say that in our experience, a majority of the AI systems that we sell, based upon system count rather than total GPU count, are delivered with this kind of balanced hardware configuration, because most people are actually running mixed workloads or thinking about architecting for a mixed workload. So it's often not to build a balanced system like you might see architecture-wise on the left, but it ends up being a frequent choice and not necessarily a bad one as well. And then if you evaluated your data set and you found it was simply too large, it couldn't fit into any chunks, for example, you have some choices to make about what you might deploy. But 2 common templates that we see is someone going out and deploying a Power 9 system with coherency. So you have a problem size that's so large, couldn't possibly be split up. You could, for example, fit it into system memory. Power 9 with NVLink is a great match because there's a high bandwidth link between CPU and GPU, and more importantly, there's coherency between it all. So the system manages the movement of data, and you do that across that unified memory space. Or you may find that you do have this data set that's way too large and not chunkable, but you have a custom algorithm too. In that case, you're going to want to consider a system that is one of these more switched architectures with a whole lot of GPUs dangled off of a single CPU, or it's a dual socket system that has all the GPUs off of that first CPU. And why do you want to consider that? Well, it turns out the PCI Express switches support a whole lot of PCI Express lanes, and the GPU to GPU communication in that kind of architecture is fast, even if the host-to-device transfer is the constrained bottleneck. So if you can get the data across the PCI Express bus, you have a large data set that spans across all those GPUs, but fits within all those GPUs. Maybe you spend a lot of time at the start on the transfer, but you never move data again. And you have an algorithm that you write that maps to that. And then there's, of course, okay, I don't know anything about my data set. I don't know anything about my algorithm, or I can't find out right now. And there's two real recommendations for that. The first is test it if at all possible. If you're working with someone good, they will make some kind of hardware resource available to you. It may not be the absolute perfect match for what you were thinking about or what you think might be the best system for that workload, but it might be close or it might be related in an important way. I know we make hardware resources available for benchmarking. A lot of our peer vendors do as well, and you should work with someone who wants to make that resource available to you. So test it. I mean, there's nothing better than actually knowing. And then also, you want to think about the fact that no matter what you choose, you may not be going too wrong. If you are starting out, for example, running your AI training CPU only, no matter which architecture of system you pick, if it's GPU accelerated, you're going to yield a whole lot of dividend from that. And even if you didn't pick the absolute most optimized system architecture for your workload, you're going to be yielding a whole lot of benefit compared to where you started. And similarly, for upgrading from an earlier GPU architecture, a Fermi or Kepler generation GPU, that's going to far outweigh any system architecture choice that you may have made suboptimally. So you'll always yield something, and it may be that you have no bad choices. So with all of that in mind, one of the biggest hiccups that we see for people in the HPC community is in finding AI and HPC expertise, for that matter, on the vendor side. So how do you create a successful interaction with someone who can actually help you architect the right system? So let's talk for a few minutes about the who, where, and what to look for on that, with hopes that you can have a more effective interaction with any vendor that you're working with. So the who to work for, oddly enough, right? Think about the people's titles. You want to look for someone who has the title of technical sales rather than sales. You want to look for someone who may have solution engineer in their title because they're going to have more technical skills and be able to more effectively help you. Anyone who's proven that they know something about AI workloads in their conversation with you, pursue them, right? They're going to be a good resource. They may know a fair bit about how to architect the right system, or at least be able to navigate that journey with you. Or anyone who's proven that they have some access to hardware for you to actually do real testing on. They're probably going to be the right resource. Similarly, in the vendor themselves, if you're looking for inside of a tier 1 vendors organization, you definitely want to find the HPC or AI group inside of that organization. Having worked in a big tier 1 vendor organization, I can tell you that it is very hard sometimes to find these people. However, they do exist, and when you do find them, they are very, very good. You definitely want to avoid people who are more general sellers. The laptop or networking guy that you're working with across campus, not the right person to look for an AI system with. In the tier 2 vendor space, you would definitely want to find someone who's an established HPC vendor, who's been around for a while, who's built a lot of systems, who you've heard has been successful at that. You want to avoid someone who's been a kind of traditional parts reseller who throws things into a box, who may not do a lot of integration or testing. Because the worst experience that you can have as an end user is sitting there fighting with hardware for 6 months that was poorly tested or wasn't integrated at all, and you get no use out of your new shiny AI system. And if you're looking for some kind of vendor side qualifications, Definitely look out for people who are NVIDIA deep learning partners. They're NPN deep learning partners. There's different gradations of them. Elite is at the highest. So start with that list. You may also look and find people in the who are qualified in the lower sections of that. And then there are signals when you work with a vendor that really tell you a lot about things. There are things that you can ask or request that will show whether you have actually worked with someone who knows what they're talking about. Ask for testing and benchmarking. If they're free to offer it or have some means of giving it to you, that's probably a good sign. If the answer is we don't have that, we don't have any capacity for that, sorry, it's probably a bad one. Ask to see the hardware architecture of a solution that's being proposed to you, even if it's a simplistic visual. If someone is actually visiting you, ask them to draw the hardware architecture on the back of a napkin. If they can actually do that, you probably have someone who's qualified on the other side, who's actually going to give you good advice. And finally, is the vendor spending time with you on the phone? Are they spending a lot of time, talking about the solution via email or in person? Are they spending face-to-face time, on your campus or on the phone with you? These are all good signs. The basic guideline is don't work with someone who doesn't understand what you're talking about. You're not going to get an effective deployment. And then once you've identified someone who you think is qualified to be working with on the other side, or multiple different vendors who you think are qualified but are trying to help refine, how do you get a better engagement out of that? The first thing that I would recommend is definitely overshare. Every piece of data about the data set that you have, about the algorithm or code that you're running, about your overall goals, whether it's I want this to run 3 times faster, I want a deployment that's twice the scale, I'm running this application, and this application. Definitely share all of those pieces of information, because you'll often find that someone who's skilled on the other end can learn a lot from it and deliver you a better recommendation of how to move forward. Similarly, about what is working and what isn't working today from your existing deployment. And also, what do you own today? Is it working well? Is it not working well? What are the specifications of it? That can be really, really important pieces of data for someone who's on the other end to help you navigate and architect the succeeding system or the new system that's going to run this workload. Definitely discuss those collaborators that you thought about early on. What do they own? Are you going to need to plan to run together? Share that information with the vendor side as well, because they'll be able to give you better and more effective recommendations. And then finally, the third piece is to state some realistic plans, and realistic is the important word here. If you're trying to plan for flexibility in the system architecture or future expansion. If your goal is to look for a system with a pair of GPUs today, but with a lot of expandability down the road, you definitely want to mention that to the vendor partner on the other side so that they can help you plan for that, whether it's the little details on the host system side or the big things. The caution of this is, of course, realistic plans for flexibility and expansion. If you overemphasize this, you'll find that the vendor is going to spend a lot of time planning for that flexibility that you may not really need down the road, and it'll compromise some pieces of the system architecture. So I can't tell you the number of times that we've designed flexibility and expandability into a system to find that 2 to 3 years later it hasn't been leveraged. So think about, are you realistically going to actually perform this upgrade down the road, or is it really just better to start thinking about how you invest the resources best today? So with that, just a quick review of what we talked about. What are the things that you need to think about before you start, right? The nature of your data set, the algorithms that you're running, the collaborators that you have, what do you know about these pieces today? Then some rough guidelines of how you might select a system for a few common templates when the data set is too large, if you're just running AI training, when you're running a mixed workload, if you don't know. And then some rules of thumb about how you collaborate with vendors, who to look for, where to look for them, and what kinds of people to look for, and how you might test them to get a better interaction. So yes, we are one of the groups that actually goes out and delivers these kinds of systems today. We delivered the first 2 DGX2s to Oak Ridge late last year in the 4th quarter. We're hardly the only vendor out there, but we're definitely one of the interesting shops when it comes to AI hardware solutions. And the hope is that you're a little less confused after hearing some of these choices and some of these strategies, and that you've gained maybe a little bit of confidence in how to select a piece of hardware for an AI deployment, and also feel a bit more confident about the vendor side too, that the best vendors out there are people who are there to partner with you and to help you navigate the journey of the piece of hardware that you're trying to select and deploy, and that you can find a good one with a few key strategies. So if you'd like to work with us or test out a piece of hardware, there's a few different ways that you can do that. We definitely do remote benchmarking. We definitely can help you with a solution. We can definitely sit down and talk about what you're trying to achieve. And if you want to dive a bit deeper into the different types of hardware that are out there for AI infrastructure, we have a great guide. It's called the GPU Solutions Guide. There's some paper ones in the room next door, but more importantly, we have an online version as well. You can browse through and see the actual prettier version of that back of the napkin, back of the envelope drawing of the hardware architecture that's out there. And we encourage you to take a peek at that. So with that, I will take any questions. Sure.
When you say data set size,
Mm-hmm.
you characterize the typical file sizes on the systems?
So it's highly variable. We have people who walk in and say, I'm working with image data, MRI images, for example. Each image is 4 gigabytes large. We have some people who say that I'm working with image data. It's 200 pixels by 200 pixels each, kilobytes in size, but there's huge scale in the quantity of them. And it becomes a large data set that way. So it's complex. There are no good answers to that question. I wish I had. But image data tends to be, and video data tend to be largest. There are other kinds of data that tend to be smaller, and it's all over the map.
But largest is 168 gigs or?
We have people who work with terabytes, petabytes of data. So.
Single file size?
Not single file size. That's the aggregate of all the data together.
The question would be single file size.
Single file size, tens of gigabytes is the largest we've ever heard of, right? Yeah.